Okay, the instructions for 15, 16, 17 are the same as 12 through 14, but now it gets a little bit trickier, class. If you think about lesson 4, or I think it's lesson 5, you see that for Optimus quilts, she's not making one quilt square. She's making 4 of them. So basically, we have to actually remove this 4 from the first 2 terms. So that's what we're going to do. We're going to factor out the 4. And we're going to be left with 4 times x squared gets us back to 4x squared. And 4 times 6x gets us back to 24x. And now we're going to actually figure out what we're going to add to that to make a perfect square. And this plus over here, we're going to go ahead and find this number, class, and then we're going to figure out that it's not the number we're looking for, it's 4 times the number, because this number will make a perfect quilt square, but we've got 4 of those. We're going to be multiplying that times 4. Let's go ahead and draw our area model. I'm going to try to draw it down here a little bit more room now for us. Okay, so now we're going to ignore the 4. In fact, we can say, class, that there's actually 4 of these. So 4 times this quilt square. There's 4 quilt squares. Here's what we have. We've got x squared in the upper left. 6x divided by 2 is 3x. Now there's our 6x divided up into 2 equal parts. That means the dimensions of our quilt square are x times x is x squared, x times 3 is 3x, x times 3 is 3x. That verifies it's a square. And then let's go ahead and figure out what number goes here. What's our missing number? We're going to add 3 times 3, which is 9. So there is our 9. I'm going to put it right here. I should have done that in it. You know what? Let's do it in a different color. We can see the difference. Let's put that in dark blue. So 9 here and 9 here. Okay, got it. So class, we had to add 9 to actually get our perfect square, x squared plus 6x plus 9. But look, class, everything in these parentheses are being multiplied by 4. So this is 4 times x squared is 4x squared. 4 times 6x is 24x. And 4 times 9 is 36. That means we're going to actually add 36 to this question to actually get it to be a perfect square. And the square of the binomial is going to look like this, class. You're going to actually write out here. You got to put the 4 on the outside. Let's do this in, I'll do this still in dark blue. So we've got 4 on the outside. Look, I'm going right to this equation right here. 4 on the outside, and then this square right here is right where we see our diagram. It is x plus 3 squared. So if you look at this, class, you had an extra step to do compared to 12 through 14. You had to remove the 4 to say, you know what, we're doing 4 quilt squares here, not just 1. And then when you figured out how to complete the square or find the number to make a perfect square in the parentheses, you have to realize every term in the parentheses is being multiplied by 4. That means technically we're adding 4 times 9, which is 36. And then for your square of a binomial, again, there's our 4 quilt squares. X plus 3 squared is the actual perfect square that you see we made with our diagram. There's 15. I'll go a little bit faster through 16. On this one, class, we can see that we have 3 quilt squares being made. So we're going to actually take the 3, factor it out. 3 times x squared gets us back to 3x squared. 3 times 4x gets us back to 12x, and then let's figure out what do we need to do to make that expression in parentheses a perfect square. Let's crank out our area model. Don't forget on this one, we have 3 of these. So I'm doing 3 times this. In fact, you can do this right now, class. You can just say 3. I'll put this in dark blue. You can actually write 3, and then we're going to have to figure out what goes inside the parentheses. We know there's going to be an x there. The question is, what is this value going to be? And technically, think about the stuff we've done before. That's our h value. A value, h value. Okay, here we go. Inside parentheses, we've got an x squared. Notice, class, I'm not looking at these anymore. I'm looking at our modified equation. We've got x squared here. We've got 4x divided by 2 is going to be 2x and 2x. That means our side lengths are going to be x times x is x squared. X times 2 is 2x. X times 2 is 2x. That's just verified it is a square. Let's figure out the number that we have to add in here. 2 times 2 is the area of this square, which is 4. We're going to go ahead and put a 4 in right there. We can actually put a 2 in right here because that was from our side lengths of our area model. This part inside the parentheses is x plus 2 squared. And then, class, to figure out this number, we can't just put a 4 here because we're adding 4 3 times. It's 3 times 4, and that number is going to be 12. Let me write that a little bit neater. The number 12. There we go. Last one, number 17. What about 5? No biggie. Oh, sorry, on number 16, I wanted to show you this. You know what? I don't think you have to put that in parentheses. I realize I put the first 2 terms in parentheses here, and then I didn't do it here. Either way, it works out exactly the same. I'm going to remove the 5 from this equation, factor out the 5. 5 times x squared is 5x squared. 5 times negative 10x gets me to negative 50x, and then I got to figure out what this number is going to be. Here comes our area model. It's all the same, class, whether we have 5 quilt squares from Optimus Quilts, whether we have 4, 3, 20, 40, it makes no difference. All the same. This is going to be 5 quilt squares, so 5 times. Here comes our numbers. We've got x squared in the upper left, that came from here. We've got negative 10x. We got to divide that in half, so negative 5x. Oh, I don't like how that looks. Sorry, class. Hard to see that. Negative. Goodness. Making too small here. I should have expanded this. Negative 5x. This is negative 5x. So that means our side lengths are going to be x times x gets us to x squared in the upper left. X times negative 5 gets us to negative 5x. And x times negative 5 gets us to negative 5x. That means, class, already in our binomial here, square of binomial, we've got 4 quilt squares. And they're going to be x minus 2. Oops, I put a 5 there. X, it is 5, sorry, I don't know why I said 2. X minus 5 squared. So we have 5 quilt squares with the same length and width because they are squares. So I'm going to put a number right here, which is this number. What do we have to do to make a perfect square? Negative 5 times negative 5 is 25. That means we're going to put 25 here. And now, class, we're not just adding 25 to the whole thing. We're adding 25 to one of the quilt squares. We got to do that 5 times. 5 times 25 is 125. So there you go.